OEM customer, TURCK Canada, with their customer Innocar.
First, what we're going to talk about, we're going to introduce Innocar, who is our customer in Quebec using our IP67 PLC, who they were great at sending some pictures and showing you the application, just so that you guys get an idea of how robust and how rugged our PLC is and how can you use it. We have several users here in Canada. We decided to work with Innocar because of their flexibility and their ability to work with our PLC and CODESYS. And it was a good example because Innocar started by not knowing and not working with CODESYS at all. So it was an introduction to our PLC, to the TURCK technologies, to IO-Link, and to CODESYS all at the same time, right? So there was a big learning curve there. But I'll let David from Innocar talk about it a little bit more later on. So to start, I'll introduce Innocar. I'll make my best attempt to speak about them a little bit. Most of the information that I'm showing you guys here, you can find it on their website. But Innocar has started designing and fabricating specialized trucks since 2011. They are headquartered in Quebec, in Canada, and they have representatives on every continent. Innocar takes pride on improving road transportation, and they have vehicles that are recognized worldwide. Their motto is quality, durability, and innovation. You can see some pictures on the screen on the right about what kind of vehicles do they actually prepare. With me today, I have David Laframboise. He's an engineer at Innocar. David, pourriez-vous vous présenter, s'il vous plaît? I don't know if we get audio from your side, David.
Yes, Jose, can you hear me?
Yes, we can hear you perfectly.
So, yes, my name is David Laframboise. I'm engineer at Innocar since almost 10 years now. So, yes, it's a long time right now. So,
yep.
And yeah, you can go ahead.
No, I was just gonna say that we're grateful about the ability that you had to start working with CODESYS from the get-go. Is that something that you can just give a brief summary of how it was a learning curve for you?
Yes, we used to have some PLC before, but just smart relays like the Schneider PLC, because we have some trucks, a lot of sensors, lot of stuff, and we change everything for TURCK with the CODESYS, just to be able to get a little bit more than what we used to have with the smart relay. Able to log some information, log some status, and provide more to the customer.
Thank you very much, David, and we appreciate you being part of the presentation.
Just by the way, my name is Ben Pham from Innocar also. Okay.
Oh, Ben, fantastic! I didn't know you were there. It's great to have you too.
Yes, good. I'm the CEO of the company. Okay. Just to let you know, perhaps what I can add on what David just said, so from this, we want a system at the beginning, something that make the unit much safer, okay, on the tank truck business, especially when we carry gasoline and so we need something much safer than just what the people used to have here on the truck business. So we want something that's much smarter, and that's why we started installing some sensor. But at some point we found out that, like David said, that it's not we cannot grow with the system that we have before with the smart relays, okay, with the Zelio, whatever, the Schneider Electric. Before that was Cruiser. So that's what we want with the more sophisticated or more actual units. So that's why we go with the CODESYS TURCK PLC. So that's why I think by going that direction, we're able to program it, make more units more automated. So that means we can use much more analog signal, and more digital signal. And also with TURCK, that's say that the IO-Link system, that would be much easier for us also. So that's why we go with that direction right now also. So that's the reason why we go with the CODESYS, because we think that it's much more, especially not for now, but for the future. I think the possibility is almost endless. Okay.
That's correct. Thank you very much, Ben, for your participation. Really appreciate you saying that. So I'm gonna continue on, and David and Ben, feel free at any point to make some comments. The idea is to showcase your experience as a user with CODESYS and with the TURCK devices as well, as you mentioned. So feel free at any point if you have any comments. Feel free to chime in. So the next point on the agenda is we're going to talk about the application details a little bit, or of what Innocar actually does, and then where does TURCK come in. So this is what Innocar's vehicles look like. They basically have tanker trucks that are used for the sale of petroleum products. They have a wide range of models and volumes. They have aircraft refuelers designed to refuel planes with JA or AV gas. They have fire trucks built to European and American standards. They have specialty vehicles that are designed to meet the needs of municipalities and construction sites, as well as tank trailers. I believe right now, correct me if I'm wrong, David, but you're participating with TURCK's PLC on the tanker trucks, aircraft refuelers, and some of the specialty vehicles as well. Am I missing any of those, or is there any category that you're also looking to implement a CODESYS control system? Yep. I don't know if we can get your audio, David, again.
Okay. Yes. Yes.
Yeah.
We just lost communication, but yes. Like you said, Jose, we're using mostly for the aircraft refueler. That's very useful because we have a lot of sensors on the aircraft refuelers, and tanker trucks. We use a lot now. We implement some HMI to our system, to our device, and it's very useful right now to get the HMI, to get a screen for the operator. So instead of having a whole way to do with pneumatic toggle switch and pneumatic push button, and everything is pneumatic, so we change everything to get a HMI screen at the back of the truck, so that the operator can operate the truck through the HMI, and it's more easier for him to operate the truck.
For sure, and you did a fantastic job putting those HMIs together. So to talk about a little bit about the old way of doing things, this is kind of how it looks like, the way that they were doing things before. There's lots of wires. It was very difficult to do the troubleshooting. When I mentioned the redundancy, it's because of something that David mentioned when we were talking about the application. The fact that they now have HMIs in the cabin and outside the truck as well allows them to have some sort of redundancy for the control and the operation from the driver, right? The driver can go to an HMI on the left side of the truck and control every aspect of a refueler truck, for example. But then if something were to happen to that HMI or that side of the truck, let's say it's blocked, they could walk around the truck, go to the other side, and still use the HMI without any issues. Like all the HMIs are sort of programmed in a way that they can have access to all the possibilities from the truck. Whereas before, they're used to have some push buttons and some knobs that if something were to happen, then you pretty much have to get some maintenance to fix the issue on site. And then there's no smart features. There's no device smart replacement, let's call it that way. If something were to happen, you'll have to wire it up or program the sensor and so on and so forth. And that's where we come into the solution details and what was the implementation that Innocar did with some of the TURCK system, some of the remote IO, some of the connectivity that we provided from TURCK, and a lot of that stuff that from the vertical pyramid that Roberto was introducing. So when you look at the system that is shown on the screen, you can see that we got the, so I'm just going to get a laser here to point it out. We got the PLC somewhere in the center in the cabinet. DS is what they call driver side, and CS is what they call the curb side. And so the idea is to have some HMIs spread around in the system. The system has a TURCK PLC as carrying all the CODESYS PLC program functionality. And then there are some other blocks like the IO link block, some blocks with analog inputs, some block with analog outputs, some slave blocks on IO link for just discrete input outputs. And to make it in one way that was plug and play and easy to use, there's an HMI on each side of the truck. There's an HMI inside the cabinet. They added features as product detection, which is an analog sensor to distinguish what product is in the tank. Temperature sensors are analog, and a lot of the sensors are now log. This is kind of how it looks like, a description of the whole system and the whole sensors and devices that they have connected. You can see that they have a lot of electrical air valves, sensor connections, IO distribution. This is kind of like just the general view of what they've implemented in all the blocks and all the connectivity that they have. So to talk a little bit of it, this is an example of one of the HMIs located inside the cabinet, inside the cabin, sorry. On the left side, you'll see this is a 360 camera to check the watering on the trees. Correct me if I'm wrong, David. And then on the right, we have the HMI to control the volume of the water that's going to go, and the pump control as well. Obviously, this HMI is connected to our TURCK IP67 PLC, which we'll show in an instant. So we're just going to go around and show different pictures of the system. But feel free, if you have any questions, to let us know through the Q&A, and maybe we can go back and show the screen if we need to explain something else. This is the first project. I believe, David, this was the one that went to Puerto Rico, and this is the look inside the cabinet. And this is the HMI, the first attempt of creating an HMI with visualization for showing the whole functionality of that refueler truck that was going to go to Puerto Rico. So as you can see, there's some sort of control for the tank level, and as well as some pressure and some pump control on the right that was created by Innocar. Then we go a little bit more in the different locations of the truck. You can see on the left, these are actually IO link hubs. These are discrete input-output blocks that communicate to an IO link master block device that's somewhere else in the truck, going from those cables in. There are some pressure sensors here that are connected to pneumatic lines that go to the right side. They're actually controlling the pressure for brakes, bottom load, and some PTO, which are the monitor devices that you see on the right. There's actually also an HMI located in this location to check out all the information. And what they're actually doing with a lot of these sensors and a lot of these devices is they're logging all of that information for maintenance purposes as well, and for checking for the driver's behavior, to see if they're actually doing the right steps when they want to engage PTO, when they want to do different things in the truck. That serves them as well to know if something was not operating correctly as the operation entails. Those are the procedures that they actually have. And they've actually added some visual indications of different stuff as well. So you can see on the left, for example, they will illuminate certain buttons in green or leave it at gray if some things are not correctly set. So for example, if you don't have the parking brake engage or the brake engage for certain steps, then the light will not turn green and all that kind of stuff. They have also indications of the product, of the tag of the product that they're actually using. And these are actually shared amongst the different screens. I think using CODESYS variables, they're actually network variables. They're sharing the information that's located on each tank and the product that's located on each tank, to have a way so that anywhere that an operator is looking at a screen, they know what is actually happening in the process of the truck. They have some different screens created as well on the HMI for measure settings, selecting the pump, and so on and so forth. Now, this is a look to the, I think the one you see on the left is the analog input-output block. The one you see on the back, I believe this is either the IO link block or the TBN PLC block. No, actually, I think the one on the right is the TBN PLC. The one on the left looks like to be an IO link block. Now, in the first project, the interesting comment that David made to me when we were discussing this is, first project, they were a bit concerned with having the PLC in the exterior of the vehicle. They wanted to have it in the cabin just in case something were to happen. I believe after that, they tested and tried the PLC outside in the exterior, and they've realized that it can survive. Again, it's rated for some of the Canadian stuff as well as some of the international stuff, like temperature to -40, temperature to +70. Those are the important things. The class 1 division 2 then probably can become relevant depending on the area and location where you're installing the PLC. ruggedness with the vibration, the 20G rating on the PLC allows it to withstand a lot of vibration as well, and how compact it is, the fact that you don't have to put it inside a cabinet and all that stuff are contributing factors for that PLC for sure. And then I think I have some pictures of some of the products from Innocar as well. This, David informed me, this is one of the biggest refuelers, or I think it's the biggest refueler in the market. It's called a 10K refueler. The one you look specifically on the screen is an archive picture, like you say on the news. It doesn't have the TURCK system installed yet. This looks a bit different when they have the control from TURCK. But it's just an example of the kind of vehicles that Innocar is putting together and sending internationally. This, I think, is actually sent to Vietnam as part of their worldwide reach that Innocar has from Quebec. And then they also have some different products. You can see in the left is a 5K refueler. In the right side, they actually have another type of refueler truck as well, the refueler tank, I believe. These are using the TURCK system. You can see that it looks a bit different on the way that they've set it up. There's an HMI actually located in there where the operator can work with the truck and whatnot. And I believe last but not least is a truck that they're using. This is an interesting application. They're using it in the city of Montreal. And what they're doing is they're watering trees, and they're supposed to monitor the number of volume, the volume that they're going to have to water each tree. So the operation of the whole watering process and all that stuff is what's carried out through the use of the camera that we saw in one of the pictures, and as well as the HMI with the TURCK PLC as well. Okay, so moving on, let's talk about the last point of the agenda, and I'll invite David and Ben again to chime in at any point as well. I try to gather some information from them on what were the key success factors for TURCK being a partner with them, as well as using CODESYS as a program PLC to basically control everything that they needed to do in regards to the their application. And part of the stuff that I gather, number one is it seems that it's getting harder to get manual labor in some of these companies. It's hard to get employees that are in the electromechanical area that have to wire and are ready to do some of the work of wiring some of their products. So Innocar really liked the experience of making everything plug and play, making it easier for connect the different devices, the PLC, as well as the different blocks and the different sensors that they have without having to strip any wire. Just going with the connectivity from TURCK, M12 connectors, some mini fast connectors for power, and so on and so forth. They also wanted to do a smarter design, adding features with analog sensors, alarm, using retained variables for logging, counts on how many times they run the pump, and logging events that they can display on the HMI. And you use this information to check how a driver is behaving, if the correct operation of the vehicle is happening when they have maintenance called, and so on and so forth. They received some training on CODESYS from TURCK Canada. I trained, had some sessions with David to the best of my abilities, training him with CODESYS and walking him through starting the project and how to work with a PLC program like CODESYS. They like the fact that it's a free software. For them, CODESYS, they can download it and can go to the website, and they wouldn't have any issues to that. And they used IO-Link as a technology as well, quite successfully in the project. They can replace sensors, like they can replace lights, for example, and the lights are programmed for certain colors, certain things, but they don't really have to program the light again. They just use IO-Link. So when they need to replace it, if something were to happen to one of them, it's just simply disconnecting a cable and connecting a new light, again with that plug and play function from our cables. And it makes it so that the vehicles can have easy device replacement. We know how critical these different vehicles are for different industries, and you want to make it easier to not have any downtime, especially from the control system. Other things that they mentioned as well, they had a learning curve, of course, with working with the variables, the bits and bytes, and CODESYS in general. Innocar was using Mac OS, Macintosh before, and well, I think they still do, but they had to get accustomed to use PC and Windows to handle CODESYS. And they started using some of the functions from OSCAD, for example, for scaling some variables and so on and so forth, some libraries from CODESYS. So, and I think that's it. I don't know if David, Ben, you have anything to add to what I just mentioned with regards to the key success factors.
Not really, Jose. I think you gave a good a lot of stuff. So no, everything's fine for me.
Yes.
Thank you very much.
I just added that something that's first. I think the support that we have from TURCK is very important, especially when we start implementing the CODESYS, because you need people that know the products, plus also how to communicate together. So just for us, I think it was very important that the organization TURCK make a lot of effort to make it happen, because that's I want to add that, because you cannot start a project like that without help from your partner, especially in that kind of products. Okay. So I want to add that, and yes, and I think Jose summarized a lot of things happen, in that. So that's what it's true. The labors go down for us, and also I think it's one thing that for us, what we found that very, very interesting is we're able to centralize the knowledge. Okay. That's one thing that we wanted before, and that's with that kind of system we're able to centralize a little bit more the knowledge. Okay.
For sure, and like you said, the possibilities then later on become endless with a lot of the stuff that it's being offered. And thank you very much for saying that stuff. It is really important to us that we can become a partner for you and help you guys and guide you through the process for sure. I'd like to thank you guys both for your participation on this. I know it was sort of last minute with certain things, but I think it turned out great, the information that you guys provided. So I think we're all good for TURCK, Roberto and Jesus. I think we're good, right? We can pass it back to Chris.
Yep. And it's done by my side. Thank you very much, Chris, for the time.